right, good morning, guys. We're on day 2, part 2 of this build. Today, we brought in an all-star to help us get this manifold to fit. We got Josh in the house. As usual, he's ready to lay some dimes down and get this piping to fit this manifold. So I'm gonna try to get some good video showing some welds today and some good stuff on that. And then after we get that piping done, we'll be able to finish this thing, get it all together. And then we're gonna do another part video for the tune. So stay tuned, here we go. All right, show us what you did here. You did some pretty amazing work here.
So first of all, I just want to show you the awesome HMS weld table here. More conductive than most metals.
Okay.
So I had to hack the ETS pipe. I've had to do this before to fit the process west intake manifold. What I did here was this bend normally curves a little bit too far that way, so I cut it halfway through the bend, put a little extension on it, cut the bend here, extension, and then a straight piece of the clamp will sit right here. It's the exact width of the clamp there, so it's about as much as you can do because you don't want to clamp on the bend. So
that looks good.
Actually fits pretty damn good.
You kind of did like a pie cut.
No, actually it's not. Pie cuts are actually off tangent. This is still a piece of metal bent tubing, so I just cut a section out of the pipe.
Oh, I got you.
Pie cut basically means that you're taking a straight piece of tubing and then you're cutting it off tangent. So I hate pie cuts.
Okay.
But what you notice here, actually, see this fits not that well because this tube is actually deformed from bending. So the tube's not perfectly round.
Gotcha.
So it'll be all right.
Cool.
If it's just enough.
I like it. It's gonna look good.
Yeah, he's gonna probably paint it or something afterwards, like a black.
He's gonna powder coat it.
Okay.
Yeah.
That should be fine.
Yep.
And then I got the bung off of there too.
Oh, nice.
Yeah. So I don't know. To find a spot for that. And
yeah. Sweet. Well, as always, Josh killing it here on the fab weld jobs. Always amazes me every time what you can do without much. Like, that's the biggest thing I've noticed. Like, you're able to make stuff happen without having like everything, which is pretty cool. Yeah. A lot of guys are like, if you don't have the stuff, they throw their hands up.
Just to say that, so this is the scrap that I have. This is all the scrap I have left. So I really can't even do anything else.
I like it.
Here's the bung. We can save that.
Oh yeah.
So I'll
sweet.
Just sand this down and
oh yeah,
hold it right in.
Look at that. Even save the bung.
But that's all the scrap. So
you know, I bet you if you were stuck in the middle of nowhere and you had nothing but like a battery and some wire, you could make some stuff happen.
Yeah, probably.
All right, well, he's gonna finish doing that, and then we're gonna get that piping fixed on this thing, and hopefully we can get to working on this and keep going on it. All right, while he was doing that stuff over there on the STI, we decided to work on Scarlett's transmission a little bit. So tore the gear set out of this thing, unfortunately. Tore it all down. I wasn't happy about it, but was able to get this shaft done. So this gear is changed out now. It's correct. We got the right gear on there. Unfortunately, the driven shaft, I had an issue with the nut on the top. I could not get it off. And when I tried to use the socket I was using, the setup, it actually damaged the bearing that's on top. The bearing still spins smooth, but you could see it dented it a little bit, and it kind of had a slight noise in it, which it probably would have been fine, but I'm not going to take a chance, so I got to order that bearing, and then we'll get that shaft done. And then finally, we can get this thing back in the car and get it done and working properly. So just wanted to give you guys a little update on Scarlett's transmission because I get a lot of comments lately asking what's going on. So that's what's going on. I'm going to do another video when I finally assemble this thing and put it back together, get it in the car and do another test drive on it. So
smells like burning ETS.
look at that. That looks good. Gosh, you're over here on literally a piece of metal on a wood table. You cracked me up, man.
I've used a barbecue grill for a welding table before.
You know you're good at welding when you can just do this on a wood table with just a small little piece of metal. Just blows me away. All right, piping's done. Look at this fit. Loving it. Got the bung welded on here, moved it to a different spot so we have the bung we need for the IAT sensor. But yeah, looks really good. Clears the fill cap, which is awesome. I'm really stoked. Knocked it out of the park as usual. Look at that. Sensor will screw right in.
Right in with our nasty threads.
Yeah. There it is. Sweet. All right, it's looking good. Thank you, sir.
You're welcome anytime.
Always a pleasure. Does great work every time. Never have an issue with this guy. So awesome. So now we're going to get started on getting the fuel system together, get everything plumbed up, put the wire harness in it, finalize all the piping, and then this thing will be ready to rock. So let's get to the next step. All right, so we got the intake manifold, everything torn back off now that the piping's done. We're going to pull the turbo and we're going to finalize the turbo. So we're going to put the oil and feed and drain and all those fittings on the turbo, get it mocked up where it's going to be finally. We're going to change this feed line out. This is an aftermarket one. It came with the new one, so we're going to put that on there. Then we're going to get the exhaust on. And then from that point, we can put the TGVs on, get the wire harness on the engine. And then we can put the crown jewel on top, which is the Process West manifold. So see her over there looking good. So that's kind of the way I do these. I kind of just do it in layers. So I put the TGVs on in the fuel lines and the fuel system first because it's really easy to get to without the manifold. Then I do the wiring and then I do the manifold. So I do it in that step. And the way I do it, so when you go to take it apart, you can do the same thing. You can just pull the manifold off first, wiring. So it's easier to work on that way instead of making it all one piece like a lot of people do, where you got to like get all this crap out, just like the stock one. You guys saw how hard it was to get stock stuff out. So yeah, I've got a couple other little things I need to do. These AOS lines are not going to work anymore with the rotated kit. It had an IAG over here in the corner. That's not going to work anymore. So we're going to move it to the middle if we can, off to the side here with a little bracket. And then we're gonna have to replumb everything. We're gonna have to convert it over to the competition series because it's a street series. So we've got a little bit of work to do. It's a lot of little stuff, little tedious things that take time, but it's gotta be done. So yeah, so I'll start pulling this turbo off. So these turbos are held on usually by a V-band. I put just a regular nut on these V-bands. This is kind of a little trick that I do. And the reason why I do it is because anybody who's worked with these V-band clamps knows that when you use the regular nuts that come on these, 1 or 2 times up and down these threads and they're ruined. So I can literally run this up and down as many times as I want, and this clamp will last literally forever. So little pro tip for you guys there at home. So yeah, we're gonna take this now. So the way these turbos are set up is we have basically a drain flange here. This is where the oil returns from the turbo to the engine. So this is the ETS supplied tube that they supply, and this is going to go on the bottom of the turbo here, and this is going to connect to the cylinder head with a hose. Pretty long piece because the turbo sits up high, but there is a gasket that comes with these. So basically there is a I don't know how to say it. It's made out of like paper, but this little gasket here is going to go on the flange between the turbo in there, and we're going to put a little bit of RTV on there. Now I know some people are going to be watching this saying do not ever put RTV on these flanges because you clog up your drains and whatever. Well, I'm going to do it anyways. You know why? Because I know the proper way to do it. Just like anything, if you put too much of anything, it's a bad thing. You put a little bit, it's not going to be a problem. I've never had an issue. The key is you just put a very, very light coat on this, both sides of this gasket, and you're not going to have a problem, because you can even see you would have to put so much RTV on that to clog that it would be obvious that you're not doing it right. So I'm going to go ahead and clean this off. I'm going to pull RTV on here. And the reason why I put RTV is because if you don't, these things will leak every time. So personally, I don't like oil leaks. I mean, some of you guys, maybe you do. I don't know. Nothing's more frustrating when you're under your race car doing an oil change and you see your turbos leaking. So I think everybody can agree on that one. So you always got to make sure these flanges are clean. So we're going to wipe it down, because anytime you have oil on this flange, the RTV can't do its job and it's not going to seal properly. So And the other reason is because when you put the RTV on here, if there's oil, it'll smear and it'll bulge out where it's not supposed to go, and we don't want that either. So ultra gray, my RTV of choice. That's what I use on pretty much everything. So Louis. So we're just going to put a little light coat on here. That's it. Okay. And then we're going to take our finger and we're just going to put it where we want it to go. So we're going to thin it out with our fingers so we don't have a lot of excess. That way we can guarantee that it goes exactly where we want it instead of where we don't want it. Let's see here. So this flange, you can see it has kind of an angle to it. So that's important because it matters which way it goes. So mock it up here. Make sure we clean off our turbo side flange. Just like that. So yeah, we're going to put this on the turbo, and then once this is on the turbo, then we can put the V-band on for the final time and get it all clocked. All right, so now what we're doing is we're getting the turbo in the right position here, mocked up.
Oh,
so we've got the turbo mocked up now. We've got the drain tube on here. Everything's just, you know, pretty much loose right now. We're going to do the feed next. So they've come with really cool. They give you all the fittings in these turbo kits for everything. So pretty convenient. Definitely put together a pretty good kit that comes with all the stuff. So there's these little proprietary adapters you need for Subarus, and basically it goes to get you to an AN because this side of the engine that comes off the little feed line here, this is not a typical AN style fitting, so that's why it's hard to find this little adapter. So, and of course Gus over here does not approve.
Gus.
He doesn't like that fitting either. But yeah, so I remember when I was, making turbo kits when we were doing ours, it was really hard to find that little fitting, and I spent a lot of time doing it. Wastegate time. This is going to be a good topic for everybody because there's a lot going on here that a lot of people have issues with. And how do I know this? Because whenever I'm on the dyno tuning cars, I have this be a problem a lot. So I'm going to show you guys what you need to do here when you're setting up a brand new tile wastegate, because these are totally different than everything else. So as you can see, it's not supposed to do that. That means there's no springs in it. They're shipped with nothing inside of them. So what they do is they are very nice to supply all the parts you need, but you got to put it together yourself. So let me see if I can find a table here to show you guys. So we have the valve, very important piece. This is called a fire ring. This is what I call it. It's actually a valve seat if you want to look it up and be politically correct. But that piece right there goes inside of here. So that fits in there like that. If this is not in here, which I've had happen before on the dyno with other people that have brought cars in, it will not boost correctly. This wastegate will not work properly because, I don't know if you guys can tell, but as that's closed, there's still a gap all the way around it because you're never going to get machine surfaces that tall, that tight with making these mass produced. So they have this little ring that goes in there and creates a perfect seal. So very critical. Make sure your fire ring's in your wastegate, people. Okay. The next thing, they ship these wastegates with all kinds of parts. So I'm going to lay all this out for you guys and explain what all these parts are for. So something I don't see that they include anymore, which was kind of interesting. They used to include another flange. They looked just like this, but it wasn't this. And that was really confusing for a lot of people because I had a lot of people say, oh, well, I got this extra part and I don't know what to do. Well, what it was for was actually so that when you made your own dump tube, it was the flange, the V-band flange for the other side of this. They don't do that anymore, which I guess it's kind of a good thing, but anywho, on these tile wastegates, this is an MVR 44, and they have actually the ability to water cool these as well. A lot of people don't do this. So if you look on the sides of these ports here, you'll see they're marked air. And if you look, H2O on that one, air, H2O, air. So basically, you have the ability to run coolant through this wastegate diaphragm to keep it cool. Now, why? Well, on the cars that we build, we usually don't ever need it. But on a track car, let's say you're building like a road course car, for road course, it's gonna be like always on boost the entire time you're racing pretty much. That's kind of important because when you get all that heat built up in here, that diaphragm can start to get compromised over time. And it's actually a good idea. So if you're building a time attack car, a hill climb car, something that's going to be in boost all the time, constantly at high loads with a lot of power, it's a really good idea to use the water lines on these. For the drag cars and the street cars we don't use them. We don't have any issues, but we're not on full throttle for more than 30 seconds, if that. So that's why it's not an issue for us. So I suppose if you're using different fuels, also could be another reason. Maybe you're using, I don't know, nitro, or if you guys are baller, you're gonna run some of those fuels. They might get a little hotter, might be a good idea. So for our application though, we don't need to. But they do include all of the fittings to run water lines. So these are the water line fittings right here. They're these little 2 AN fittings. And they also include, I don't know why that didn't stand up. We got plugs. They gave us 1 gasket. Oh, there's 2. I was gonna say there's supposed to be 2. So these gaskets are for the water lines so they don't leak. So they give you 2 of the little gaskets in there for the water lines if you need them. Just like that. And then these here are the ones we're gonna definitely be using. These are the barbs for the lines for the wastegate. So these are where the vacuum and the boost come in to actually make this thing do its job. So there's lots of different ways to hook up a wastegate. You can run all different kinds of setups. It just all depends on your application, your spring size, your turbo size, your back pressure, everything. So what we're gonna do today is we're gonna show you basically how to hook this up the way I think it should be hooked up for this application. We're gonna be running 40 PSI on this car. So typically, if you're running a 3-port versus a 4-port, it makes a big difference. So if you're gonna run a 3-port and you're gonna run 40 pounds of boost on one of these, you're gonna have to run a lot of spring pressure, because the rule is typically you can only double the amount of boost per spring that you have in here. So the way that works is all these springs have different colors and different tensions. Now, when you mix and match these springs, you can get different pressures. So there is a chart that Tile has. It's not in the box, but it's on the website. Well, they will tell you what springs to put inside of here for what kind of gate pressure you want. So let's say we're running a 3-port and we want 40 pounds. Well, we're gonna have to run like 20 plus pounds of spring in this thing, which is a lot. So that'll probably work out to being all of these springs together, if I remember correctly. I think there's like 24 pounds of spring you can actually run. But my favorite way of doing it is I like to run 4 ports. The reason why I run 4 ports is because you can run a lot littler spring inside of here, and you could have a bigger range of boost, which is nice. Because let's say your car starts knocking and getting detonation. Well, you can actually set up the tune to drop the car back down to wastegate automatically. But if you have 24-pound springs in here, that's still a lot of boost. So it doesn't really, like, let's say you're on pump gas and you're tuned for 24 pounds. Well, you're not even going to have any room to bring the boost down for failsafe. You're still going to be on that hot boost all the time. So with a 4-port, I can literally put a 7-pound spring in here and I can run 50 pounds of boost. Hopefully that kind of helps you guys, understand a little bit. It sounds really complicated, but it's really not. It's very simple the way these things work. And when they work great. So tiles are good. There's nothing wrong with these wastegates. They're not my personal favorite because they like to boost creep a little bit in my experience, but they do work fine. So for this application, we're going to be putting in a 14.5 PSI spring setup in this. And then with our 4-port, we'll be able to run as much boost as we want. So we're going to open this up. I'm going to take all these Allens out and I'm going to show you guys what the inside of this looks like so we can set it up. All right, so unfortunately there was no green spring that came in the kit, so we can't do 14.5. but what we can do is 15.9, which is close enough. So we're gonna do yellow, red, and black. That's what works out to on their spring chart. So I always like to pre-compress them to make sure that they're in these grooves properly, because there's little grooves in here these springs have to seat in. Now the hard part here is you have to take this cap and you have to push all this down and then put all the bolts in. It's really a pain in the butt, right? And usually it takes like 2 people and 1 guy getting the screws in real quick, and it's a big deal, right? Well, I'm gonna show you guys a hack. So I'm gonna show you guys the easy way to do it. This is where we should insert the meme, 1 hour later. Be cool that also. All right, so we're gonna open this up. We're gonna take a nice clean towel-ish. And then what we're gonna do is we're gonna clamp this basically inside the vise, which is gonna make it easy for us to put the springs on. So we're gonna make sure we're gonna put this in the right location for where we're gonna run this side fitting here. So typically, you know, you guys can clock this wherever you want. I mean, we're gonna use this one. I don't really use that one. We're gonna plug it so it doesn't really matter too much. If you want your logo to be in a certain spot though, now's the time to do it. So I'm gonna try to do this and not look like a complete idiot on camera. So we'll see. So we're gonna need a little bit more. Now what you do is when you're doing this, you want to make sure you keep it kind of centered and just kind of guide it with one hand so it can't really spring out. See how it's trying to go down? The springs are going to want to kind of do what they want to do to a certain point. But once you get it down there, it'll lock in. So I usually just kind of guide it in. Get her lined up. Just take your time because you don't want to. Okay, so we've got it close. So like I said, the trick is just getting it lined up just right. Just like that. Yep. So there you go. So now you just put a couple bolts in it, and that's it. That's the trick. So you guys saw it here. Of course, a little bit off. So yeah, once you run a couple screws in it, as soon as you get these holes lined up, that's the trickiest part, is just getting them perfectly lined up. So just be patient. Don't get, you know, impatient and just try to ream these in there because it's not going to be good. So there we go. I got it. Somebody's breaking into the compound.
Scared me too.
Good thing we have good security here.
Does anyone want a dog? Jeez.
That's it. So there you go. Now we're going to take this back to the car. We're going to put it on the car and then we'll be ready to go. All right, so we're doing the final assembly. As you can see, I've got all the ports fully dressed. So you guys got to remember, so this is important. Depending on where you put your fittings for your boost lines, you have to plug the other ports you're not using. If you don't use the supplied plugs, the wastegate will not open and it won't work. It'll overboost, could blow your engine on the first pull. So told you we have a top and a bottom port, right? So we ended up using these because on this turbo kit, I'm gonna run my lines real clean out the side. So we're gonna use this top port. We're gonna plug that one so that when boost comes in here, it holds inside here and actually seals. The bottom, same thing. We're gonna plug the 2 other air ports on the side And then I went ahead and put the H2O water lines on anyways, because if the customer ever decided in the future they wanted to sell this wastegate or hook water up to it, it's easier just to have the fittings already there, just not connected to anything, than to have to lose them or something happens. So I always just stick them on there anyways. But so once we get that in there, we're gonna put our valve seat. Don't forget our valve seat. And then we've got our V-band clamp to hold this on. So pretty straightforward. Make sure all your bolts are tight always. So go back and check all the torque on these bolts, and when they're all tight, you're good to go. You can go ahead and torque these down, then we're gonna put on the car. All right, so the next step is we're gonna pull the stock wiring harness off the old manifold, and then we're gonna swap it over to the car. So we need basically everything on the wire harness except for the manifold and whatever is attached to the manifold. So I'm gonna go ahead and take this harness off, get the injectors unplugged, and on the bottom here, they usually hold the harness to the manifold. So there's a couple of bolts here. That's good. There's one here. And then what I'm going to do, what I always do, is I thin this harness out. I take all these black guards off, and I trim it down to make it a lot cleaner, so that when you look at the engine bay, you don't have a bunch of those stock bracketry that doesn't really matter anymore. So it's kind of one of the little things that I do just as a personal touch on my builds. You don't have to do that. You can leave all the factory plastics and whatnot on there if you want. So once we get this out, so there it is. So this is the factory harness that's we're gonna reuse. So we're gonna make it look prettier by trimming it down a little bit. Clippers. There's a couple different ways you can do this. You can do the basic trim, which is what I'm gonna do, or you can do the very in-depth, involved like trim where you cut out all the connectors you're not gonna use. And basically what I did on my race car is I just took the stock harness, unwrapped the whole thing, trimmed everything out that wasn't necessary, and rebuilt the harness connector by connector, which is very time consuming. And it's overkill for this project. Because this vehicle is actually going to use almost all the connectors, so there's really no point in even doing that anyways. But we're just going to minimize, you know, the stuff that's clutter, like we're taking off all these factory guards and all the little crap. So it's just going to make things look a lot more clean, and it's going to complement that Process West a lot better. So you can see now. All right, so a couple things here with this Process West. So when you go to install this manifold, if you look, there's really no vacuum ports or anything you can see when you first look at this manifold. So to connect all the wastegate lines to boost sources and all that, you know, you kind of figure, where does that stuff go? Well, it's kind of cool the way they did this manifold. So they actually did it on the bottom. So I don't know if you can see here. I'm trying not to set this down on its top because I don't want to scratch it, but see there, they did them on the bottom. So these little holes here, these are all the vacuum lines. You can see I already had to go to the hardware store and get some brass tees for this. I got a 90 for the brake booster, and I got assorted different fittings and couplers for the other ports. And I also got some pipe thread compound that we're gonna seal that stuff up with. So I'm gonna go ahead and start putting these fittings in this manifold and get these sealed up, and then we're gonna go move to the next step. All right, guys, here's the finished product. So we've got the fittings in there, plenty of vacuum lines for all our sources. And we've got the brake booster one on here for the brake booster. We're gonna put a one-way valve in between the booster and the manifold. All the threadings are pipe thread sealed in now. And what's really cool about this stuff, I know I mentioned a little bit, but a lot of people try to put tape, thread tape on here, which it will work, but you will have issues with these fittings backing out with vibration I've had in the past. So this stuff here, it's not really, I mean, it's kind of like, you know, a thread locker, but it's not. It's made for pipe thread, and what it does is it hardens up, and once it hardens and sets, it pretty much glues these fittings in, so there's no way they can leak and they won't vibrate out. But if you do have to remove these fittings for any reason, they can be removed still, and this stuff can be cleaned out. But you know, it's not really a JB Weld. It's kind of like it, but it's not as aggressive. A JB Weld, you know, once you put it in there, it'd be one with the manifold. You'd never get it back out. So this stuff is what I recommend using on this project here. I've used this on a lot of them. Never had an issue. It works great. So little tip for you guys, if you're doing Process West manifolds, this is the way I do it. Give it a shot if you want to try it. About is vacuum line. So for all these fittings on the wastegate and for the, you know, fuel pressure regulator, boost controller, all that stuff, you really got to use quality lines. I see this a lot on builds like this. You put a big turbo and you got an awesome motor setup, huge boost, big wastegate, and people put very, I don't know how you would say it, just very cheap vacuum line setup on it. And personally, a vacuum line can literally make or break a build when it comes to a wastegate line, and I am not a fan of doing really cheap lines because they have problems, they melt. So what I always do is, this is what I use. So here, on all my big power builds, I step it up to this braided, it's internally braided. It's rated for over 100 PSI of pressure, which we'll never see that, but this line is very thick. It's coated with a special coating to resist oil, and it's rated for actual fuel. So it's actually fuel line, and it works great for vacuum lines. This stuff is super resilient, lasts forever, and just works awesome for running boost lines and whatnot. So I'm gonna run all this heavy duty hosing for all the boost lines. It's a little more work. It's kind of a pain to deal with, but once it's in there, you'll never have a problem with this stuff. So that's why I do it. So there's another tip for you guys. You're doing a big turbo project, you know, spend the money, get the better line, do it right the first time. All right, next order of business is gonna be the breather lines. So PCV lines, again, use high quality hosing. So when you have a Process West manifold set up and everything, the factory breather line setup that goes from the balance port on the block to the valve covers on each side will not work. I mean, you could make it work, but it looks gross. It's not clean. So I like to redo all that with custom lines. So what I do is I use basically, this hose here is fuel emissions rated for PCV systems. This is not heater hose. I see this all the time where people use heater hose for this, and it will work, but it will, over time, the oil contaminates the hose. It's not made to deal with oil, and it will literally gum up, leak, cause all kinds of issues. This line here is rated for fuel. It's actual fuel line for PCV, and this is what you're supposed to be using for breather lines, guys. Really, it's a little bit more expensive, but like I said, do it right the first time. You never got to worry about it again. So I'm going to make basically a custom T here. So I'm going to come off the block. I'm going to come up with a 90. I'm going to put a T here. I'm going to go off to each head and then connect them all together, and that will take care of that. Nice low profile, stays under the manifold. You won't see it, stays hidden, and it works good. So I'm going to build those now, get these cut to length, build that line there. As far as the T goes, plastic T here you can get from the auto parts store, works perfect for this. So basically, when you come off the block here, you're going to come off with a 90 here. This is basically going to sit like this, and then you're going to run each line to each side, and it works out perfect. So all right, we got our PCV lines built, got them routed, going to each valve cover. So those are good. Now I'm going to put the fuel rail fittings in these fuel rails. Little pro tip here, guys. This is an ORB to AN style fitting. Always remember these O-rings need to be lubed up before you're putting these into fuel rails, because if you don't, they could gall up, they could leak, and they could have issues. So always put a little bit of oil or lube on the O-ring side. The AN side, you don't have to, but a little bit of engine oil is never, you know, a bad thing, because it'll help lubricate the threads. But don't put any kind of grease or anything on there. Just engine oil. That's all you need to do. And put these in. All right, all our fuel rails are plumbed with fittings. Now I just gotta hook up the lines to there. The next stage is gonna be getting this to transfer over. So this is the IAG air oil separator. It was set up as a street series for a top mount car. So unfortunately, it's not gonna really work with the configuration now, since we're a rotated car and we're not top mount, we're front mount. So we're going to convert this to a competition series. We got their kit that they sell to do that. And then we're going to get rid of all that mess and just conglomerate. Oh gosh, it's just a nightmare. I hate looking at it like that on a top mount setup. It's just really a pain. We're going to simplify all that. We're going to get it sitting up in here in the engine bay as best we can. And then we're going to move forward on that. So I'm going to show you guys a couple little tricks and how to convert a IAG street series to a competition series and how to get it to fit with the rotated kit. All right, so we're making some progress here. All the fuel rails are plumbed, fittings on, flex fuel kits run. So I want to show you guys a little bit here about this flex fuel kit. It's one of the right ways to run this. I had a lot of cars on the dyno and I've seen people make a few mistakes, so I wanted to take a minute and show you guys. So we have the flex fuel kit here. I usually mount it to the block underneath the manifold here, so when the manifold's on, you're not going to see it. Keeps it pretty neat and tidy. But the way this flex fuel kit works is back there. I don't know if you guys could see it. That's the rear O2 sensor harness. It gets its power from there and it runs down and then goes to the flex fuel module that's zip tied under here. You guys can't really see it, but I've got it hidden out of the way. I like to hide everything so when the manifold's on, just makes the engine bay look really pretty. But basically it gets its power from there. Then it runs over to the driver's side TGV connector right there and it plugs into there, and that's what actually brings the signal and ethanol content from the sensor into the ECU. Then over here, we have the fuel pressure, which is the fuel pressure harness taps in right here and goes in as well and gives us a signal to the passenger side TGV harness. So basically what I want you guys to know is when you plumb this in for fuel, you got to put this on the return side usually, but before the regulator. I've had people put it after the regulator that goes into the tank, and the problem is under full throttle, this regulator is not going to return a lot of fuel because it's holding it back to keep fuel pressure up. And so when you lose a little bit of fuel pressure coming out of the regulator to this sensor, it's going to read incorrectly. The ethanol content's going to go up because there's not enough fuel flowing through it. So plumbing it before the regulator is going to keep a constant flow of fuel pressure going through this regulator no matter what. So at all times. So just want to show you guys that real quick. You can put it on the feed side, but on cars like this, I don't do that because we're -8 feet on this car coming into the rail, and I don't want to reduce it down to this because at this power level, we need that -8 feed. But for anything under, 600 horsepower and down, you can plumb that on the feed side. It'll be just fine. But for these big power cars, this is the way I do it. I've had 0 issues and then did a lot of testing over the years, and this works really well. So I'm just going to show you guys, we got -8 coming in here from the tank through the rail. We got a -6 line running all the way over to the other rail that feeds this rail. -6 out through the flex fuel to the regulator. -6 out of the regulator to the tank. So this is basically what's called a series setup, and that's the way I plumb 99% of my fuel systems because it works out good on the street, good drivability. No issues there. You can do parallel. It's a lot more fittings, a lot more lines, and more time. But typically, parallel is when you're really trying to squeeze every little inch out of your fuel system possible. And we have plenty of fuel system for this turbo, so it's not necessary in this application. My car, Scarlet, I do have a parallel fuel system because obviously that car is pushing the limits of the fuel system in every way. So it gives you just a tiny bit more overhead. But one thing about a parallel system you got to be careful with is all the lines have to be the same length. And so, or you can run into fuel starvation issues or distribution issues. With the series system, we don't have that issue. So it just makes things simple, trouble-free on a street car. We don't have any issues with that. So I wanted to show you guys that real quick because that's a I see that a lot on the dyno lately with people doing these flex fuel kits. So I thought I'd take a second to explain that. So now that everything's plumbed, wired, pretty much ready to go, we're going to do the wastegate lines with the 4-port, and then we're going to put the crown jewel on top of this thing. We're going to put that Process West on and see what it looks like. So let's get to the next step. All right, so got all the lines routed. Everything's finalized. I want you guys to take a look at these boost lines, the way I set these up. I put the 4-port under the intake manifold. Most of the time, I usually mount it visible somewhere, but there just really wasn't any good spots on this setup that I felt to mount it. So I decided to mount it underneath. So it kind of hides some of the beauty of that little deal there, but just want to show you these lines. Look how good these boost lines look. These things are super heavy duty. Cable ties on every connection. all the way up to the wastegate. So those are those heavy duty boost lines I was talking about that in my opinion are a must for a car like this. So I spent some extra money putting this together, but it's worth it because I know those boost lines are never going to be a problem for the customer in the future. And it's the right way to do it. So a car like this really deserves, you know, the best of everything. So it takes more time and more money, but if you do it right the first time, it will be cheaper in the long run. I'm a firm believer in that. So, all right, enough talking. Let's get the crown jewel on this thing and see how it looks. All right, so I got the manifold propped up here to show you guys how I got all the vacuum lines run. So I've got basically the second fuel pump boost switch activated on this line. I've got the blow-off valve going to this one, the brake booster on the back one there. This one here is for the boost gauge in the car. And then this one is for the fuel pressure regulator. So basically I have everything has its own redundant signal for vacuum and boost. And the reason why I do that and don't just tee lines together and run fewer lines is because the fuel pressure can actually be affected if you don't have a good signal going to it that's not shared by other devices. So the fact that we have the Process West manifold, it has so many ports, we're going to take advantage of that and we're going to use all these ports because it's always better to have each source having its own dedicated vacuum port. Boost is going straight off the turbo, has nothing to do with any of this to the boost controller. So basically, let's say one of these lines pinches or falls off, the boost gauge line, the car gets a leak or something, our fuel pressure, our blow-off valve, and our secondary boost switch will still operate normally because they have their own lines. If they were teed together, we would lose one of those and we could lose the engine by leaning out or have all kinds of other issues. So this is the way I like to do it on my cars that I build for, you know, these big power cars. I like to do everything as redundant as possible, and I like to eliminate the possibility of failure as much as we can. So just want to show you guys here how I got those routed. We're going to put the manifold down for the final time, torque it down, and then we're going to be ready for the intercooler piping. All right, guys, here's the finished product. Everything's up there ready to go. Look at that. Engine bay's looking good. Really happy with how it came out. Everything's good for the most part. We just have to get the piping repowder coated in these spots where the welds were done, but other than that, looking good, solid. So everything's there. I went ahead and changed the oil so it has fresh oil and filter on it. And we're gonna go ahead and do the first start now. Got the laptop out. Got the access port connected. We're gonna go ahead and make a base map for this thing, and then we're gonna do the first start. All right, so got the map on there. Got Hannah in the car. She's gonna do the honors. Put her in neutral and then start her up. And if you hear me scream and there's something going on, shut it off. She runs good. Everything sounds good. She's just got, she's a little lean on warm up. This is just a base map just to get it over on the dyno, and then I'll take care of all that. But yeah, runs good, sounds good. So hope you guys liked the video today. I'm gonna end it there. The next video is this thing over there on the Heartbreaker. So stay tuned. Don't forget to like and subscribe. We'll see you later.